everyone. Our topic for today is the introduction of polynomials. Let's start. Algebraic expression. Coefficient. For example, the number and the letter is together. The numerical coefficient is a number part, so we will only write the number. Literal coefficient is the letter part with exponent, so we will only write the letter. Another example, 5mn. The numerical coefficient of 5mn is 5. Literal coefficient. The literal coefficient of 5mn is mn. Last example, 10st squared. The numerical coefficient of 10st squared is 10. The literal coefficient of 10st squared is st squared. Leading coefficient. Leading means the first one. For example, 10st squared plus 4st minus 7. It is a trinomial because it is 3 polynomials with 3 terms. The leading coefficient is arranged in descending. So the leading coefficient of 10st squared plus 4st minus 7 is 10. Another example, negative 5mn plus 8 is binomial because it is a polynomial with 2 terms. So the leading coefficient is arranged in descending. So the leading coefficient of negative 5mn plus 8 is negative 5. It includes the negative sign. Final example, 9x up to the third power plus 6x squared minus 12x. It is a trinomial because it is a polynomial with 3 terms. The leading coefficient is arranged in descending. So the leading coefficient of 9x up to the third power plus 6x squared minus 12x is 9. Algebraic expression. We will differentiate one by one, where is constant, variable, numerical coefficient, literal coefficient, leading term, leading coefficient, and number of terms. Let's start. 9st squared negative 4st plus 7. Constant. Our constant number is 7 because it is the only number has no letter. Variables. Our variables here is s and t because it is only the letter here, so the variable is st. Numerical coefficient. The numerical coefficient is 9 and negative 4 because it is only the number has a letter, 9 and negative 4. Literal coefficient. The literal coefficient is st squared and st because it is only the letter here, but it is not the same. st and st squared and st are not the same because the other one has an exponent. Leading term. The leading term is 9st squared because it is the leading number. Leading means the first one. So our leading term is 9st squared. Leading coefficient. Our leading coefficient is 9 because it is the first number in the term. Number of terms. Our number of terms here is 3 because number 1. Our first term is 9st squared. The second term is negative 4st. The third term is 7. So the number of term is 3. Algebraic expressions. All of these are the sets of algebraic expressions. Sets of algebraic expressions are polynomial and non-polynomial. We have here polynomial and algebraic expressions or non-polynomial. Well, the polynomial is a special kind of algebraic expressions, while inside the red circles are called algebraic expressions or non-polynomial. Once the variable is on the denominator, it is called algebraic expressions or non-polynomial. And When the variable is on the numerator, it is called a polynomial. Algebraic expressions. All of these are a set of algebraic expressions. Sets of algebraic expressions are polynomial and non-polynomial. We have here polynomial and not a polynomial. Polynomial. What is a polynomial? A polynomial is a special kind of algebraic expression where each term is a constant variable or a product of constant and variables. Thus, an algebraic expression is not a polynomial. When the variable is in the denominator, like this one, the variable is on the denominator, not on the numerator, so it is not a polynomial. When the exponent is not a whole number, like this one, negative integer, not a positive integer, so it's not a polynomial. But this one, it is a positive integer, not a negative integer, so it's in polynomial. When the variable is under the radical sign, like this one, under the radical sign is a variable, so it is not a polynomial. For example, this one under the radical sign is a number, not a letter. So it's a polynomial. What is a term? A term is a constant variable or a product of constant and variable separated by plus or minus. All of these are plus and minus except for this one. This is not counted because it is a negative sign. Let's start. Our first example is 10st squared minus 4st plus 7. It is a trinomial because it is a polynomial with 3 terms. The first term is 10st squared. The second is negative 4st. The third term is 7. Numbers of term. The numbers of term is 3. 1, 2, 3. Leading term. Leading means first. So the first term is 10st squared. Constant term. Our constant term is 7 because it has no variables. Second example. Negative 5mn plus 8. It is a binomial because a polynomial is it has 2 terms. Numbers of term. The numbers of term is 2 because the first term is negative 5mn and the second term is 8. Leading term. Leading means the first one. So the first term is negative 5mn. Constant term. The constant term is 8 because it has no variables. Third example. 9xy up to the third power plus 6xy squared minus 5xy minus 3. It is a multinomial because a multinomial has a 4 term. The first term is 9xy up to the third power. The second term is 6xy squared. The third term is negative 5xy. The fourth term is negative 3. The numbers of term is 4. 1, 2, 3, 4. The leading term is 9xy because leading means the first one. So our first term is 9xy up to the third power. Constant term. The constant term is negative 3 because it has no variables. Number 4th example. Negative 12a squared minus 4a squared plus 6. It is a trinomial. It is a polynomial with 3 terms. The first term is negative 12a squared. The second term is negative 4a squared. The third term is 6. Numbers of term. The numbers of term is 3 because 1, 2, 3. Leading term. Leading means the first one. So our first term is negative 12a squared. Constant term. The constant term is 6 because it is only the number has no variable. Last example. 6ab. it is a monomial and it has a polynomial and one term. Numbers of term. The numbers of term is 1 because it only has one term. A leading term. Leading means first. So our first term is 6ab. Constant term. The constant term is 0 because it has no term. And it has only one term. Degree of a polynomial. The degree of a polynomial with one variable is the value of the largest exponent of the variable that appears in any term. For example, negative 2x up to the third power plus 3x squared minus 2x plus 5. The largest exponent of a variable is 3. So, the degree of a polynomial is third degree. Second example, negative 9a up to the fifth power plus 10a up to the fourth power minus 3a squared minus 3. The largest exponent of the variable is 5. So the degree of a polynomial is fifth degree. The degree of a polynomial with two or more variables is the highest degree of a term with non-zero quotient. We have to find the degree of a term to sum up of the powers. For example, 12x up to the third power, y up to the third power, plus 5x up to the third power, y squared minus 4x squared, y minus 10. The highest degree of a term with non-zero is 3 plus 3 equals 6. So, the degree of a polynomial is 6 degree. Final example, 7m up to the fourth power n up to the third power minus 2m squared n minus 6n up to the third power minus 9. So, the highest degree of a term is 4 plus 3 equals 7. So, the degree of a polynomial is 7th degree. Polynomial in descending order. The polynomial in descending order if the exponent of the variable is arranged from largest to smallest. For example, negative 2x minus 2x up to the third power plus 3x squared plus 5. We have to arrange the in descending order. So, our first term is 2x up to the third power. So, this will be our first term and the highest term. Our second term is 3x squared. So, this will be our second. The third term is 2x up to the 2x. So, our third term is 2x. Our final term is 5. Second example, 10a up to the fourth power minus 9a up to the fifth power minus 3a squared. Our first and highest term is 9a up to the fifth power. So, this will be our first term and highest term. Our second term is 10a up to the fourth power. This will be our second. Our third term is 3a squared. Our last and final term is 3. Third example, 5x up to the third power y squared plus 12x up to the third power y up to the third power minus 4x squared y. The largest and first term is 12x up to the third power y up to the third power. That will be our first term and the highest term. The second term will be 5x up to the third power y squared. Our final term is 4x squared y. Final example. Negative 9 plus 7m up to the fourth power and up to the third power minus 6 and up to the third power minus 2m squared n. The first and highest term is 7m up to the fourth power and up to the third power. Our second term is 2m squared n. Negative 2m squared n. Why not 6n up to the third power? Because the first term follows by variable m up to the fourth power and up to the third power. So the second term follows by m and n. So our third term is negative 6 and up to the third power. So the last term and final term is negative 9. So the answers will be negative 2x up to the third power plus 3x squared minus negative 2x plus 5. Negative 9a up to the fifth power plus 10a up to the fourth power negative 3a squared negative 3. 12x up to the third power y up to the third power plus 5x up to the third power y to the squared negative 4x squared y. 7m negative up to the fourth power and up to the third power negative 2m squared and negative 6 and up to the third power negative 9. Thank you for watching. Goodbye.